what is Kubernetes and also what are the operations that you could do in Kubernetes. So I think just to summarize, I think we looked at various terminologies within Kubernetes, and also we saw some practical examples. In this we started with the cluster. We understand few terminologies which are again the refresher. So cluster, it is nothing but a group of nodes. Node is nothing but a host that actually runs the application. Nodes are nothing but a virtual machine. So, and the containers is where you package your software in either using Docker or any other container orchestrate, any other containers apart from Docker also you can use. But yeah, it's a package for the things to get deployed. And the pod is a unit of deployment. Where this is the smallest unit. So pod will can have either one container or multiple containers. So in Kubernetes terminology, pod is the smallest unit. Because pod has multiple containers. Containers again is not Kubernetes terminology; it is a Docker terminology or general outside Kubernetes terminology. But pod is the smallest unit in Kubernetes terminology. And the replica set is nothing but ensures availability and scalability, especially ensures that desired state is always met. And the labels are the key value pairs which are used to identify a service. And service is nothing but a collection of various pods exposed on an endpoint so that you can access it. So that is what we're looking at. And so we're just going a bit deep dive into how Kubernetes works internally. I think if you remember the demo that we did, the Hello World example. So that was a concept where we tried all the commands and how from an end user point of view how this Kubernetes will work. So we saw that. But for I think if you go a bit deep into this, first initially if you remember, we created a cluster. So cluster is nothing but a group of nodes. I'm just showing in terms of GKE, but the concept is same. Either you do it on-premise or cloud. So this is the Kubernetes cluster that we created. This is a Google Cloud Console, and I'm in Kubernetes Engine module. Inside that, if we go here, we see the cluster, which is this cluster one, and cluster has multiple nodes inside. So if you remember, we created 3 nodes. So this 3 nodes are there here. And these 3 nodes are nothing but 3 virtual machines. So which will have like your CPU or just like 3 laptops. You can imagine 3 laptops forming one cluster. So each laptop or virtual machine will have some CPU, memory, and all those things. So it's nothing but a virtual machine behind the scenes. So when you go to cloud, first thing that you need to remember is even though you are using Kubernetes, but the compute is still a virtual machine. So that is something you can't avoid. So basically, the compute you still need to use virtual machines. So that's why you need to know. Anyway, you need to know about virtual machines to some extent. I mean, in cloud. The same goes in on-premise also. I mean, if you're using an on-premise, let's say you can create a cluster with probably mostly Red Hat Enterprise Linux is generally used in on-premise. So generally you create 3 nodes, 3 RHEL servers or Ubuntu servers, and then you form a cluster. So and then it's nothing but a compute. So you need a compute where in this computes, all these 3 computes acts as a node, and each one is one node, and you generally you deploy all your deployables into these nodes. I mean, why you need 3? Again, the 3 is required again just because of again redundancy purposes. If one goes down, still there is a backup. So that way Kubernetes will ensure that even if one node goes down, still things are working fine. So, but again, it is not required to have 3. Even you can do it with 1 also. Kubernetes will work even with 1 node also. So that is something which we want to make it clear. So Kubernetes will work even with 1 node also. But I mean, 1 node doesn't make sense because then you don't need Kubernetes also for this, because 1 node, if something goes down, all the other benefits that you get out of Kubernetes, like taking care of your auto healing and auto scaling and all those things that you get for free in Kubernetes. Those will not make sense if you use one node, because if one node goes down, everything goes down. So yeah, so generally it's a good practice to use minimum 3 nodes. Again, it's minimum, so you can add more also. Minimum is 3 nodes. So yeah, that's about the cluster. So if you go a bit inside, I mean, just to show these names, I think I already showed this earlier, I guess, but I'm once again will show it. But you can, if you see these names, you can see these names also in virtual machines. So just want to show, for example, 35DR 41 whatever JM. So the same things, the same names. If you go to virtual machines, you can see them. Where is virtual machine distributed compute networking? Compute. Yeah, compute. Yeah. So compute. So compute engine in this VM instances. This is where we can see the VMs in Google Cloud. So if you go here, you can see the 3 virtual machines that we saw in GKE. Those were internally these virtual machines only. So yeah, the 35DR 41JM. So all the 3 nodes are there here. So 3 virtual machines that are created. So at the end, if you see, these are all created. These are all virtual machines created on particular zone, and they also they are in use by this cluster. This is a cluster. The information also we have. So and it has also a particular IP address for this virtual machine, and also it has an external IPs, and you can also connect to this virtual machines. So you can SSH to the virtual machines and connect to that virtual machines. So yeah, so that's all about the cluster. So if you understand cluster is nothing but a group of nodes. For example, with the 3 nodes, and in this case that we saw, there are 3 nodes, and each one is called as a node. And there's something called master, which we don't see because it is completely managed by the cloud provider in this case. But there is a master. Which will control all the 3 nodes. So this Kubernetes architecture is, I'll show you the slides with respect to architecture, but at the end it is a master slave architecture or control plane node architecture. So it is called, master is also called as control plane. Master, control plane, these are all same. So I mean, just the master slave, they want to avoid it, so that's the reason they're calling it control plane now. Master is also called as control plane, because it controls other nodes, so it's called control plane. And the node or worker or a minion, these are all various terminologies for a node, worker, minion. So these are all the real virtual machines which takes the instructions from master. So right, so yeah, so we understood what is cluster now. Cluster is nothing but a group of nodes, and Kubernetes automates primarily the distribution scheduling of your job, of your container across a cluster. Basically, when you saw the Hello World application that we deployed, it's basically Kubernetes is distributing your application in all these 3 nodes, and also it is also scheduling your job in these 3 nodes. So that way, if one goes down, still the other instances are still active and running. So yeah, it is basically scheduling your workload into these machines. I mean, the very common terminology they call is workload. Workload is nothing but your pod or primarily your container image. So generally, your workload. Whenever they say workload is also a very common terminology in cloud. When you deploy your workload, in Kubernetes terminology, it is a pod that they're referring. They're deploying, when you say the workload is copied over, they're referring your pod is copied over to all these nodes. So because pod is your workload. Yeah, so basically Kubernetes automates that, and then Kubernetes, as I said, there are 2 components in Kubernetes. One is control plane, and the other one is nodes. So I think we discussed control plane. I think control plane is a master. So it does many things which are super duper important. So for things to work perfectly, meaning it does many things. In sense, it does many things like, for example, scheduling your applications. It does that. It ensures that your pod is getting deployed in all the three nodes. And also it maintains the state. When you told control plane, I want three replicas, it ensures that three replicas are running for sure, irrespective of whatever happens. I mean, any pod, even if pod goes down, node goes down, it will add a new node or add a new pod. So it ensures that the desired state is met. So and also it scales the applications, and also it rollouts. Right? It will make the rolling out of new updates also. So all these things are managed by this control plane, and nodes are nothing but, as I said, like the workers. So they just obey the master. Whatever master says, they will execute that. So the nodes are basically, it doesn't do any decision making. It follows the instructions, whatever is told by the master. So cube basically, generally your nodes is where your workload is actually executed, which is, for example, the hello world application is the pod that we created, and these pods are getting executed on these nodes. Yeah. So any questions in cluster and nodes? I mean, it is not. I mean, as I said, as you in the diagram, it is. You can minimum is 3 node cluster minimum. So that is a good practice to follow. If you want to have all the benefits of Kubernetes, you need minimum 3 node cluster. But of course, there's no. I mean, you can increase the nodes to any number you want. There is no restriction, and it's just adding more virtual machines also to the cluster. So yeah, there are instances where people do this, check their deployment across. I mean, I'm talking about in a complex scenarios where you're a global organization, and you have multi-region setup. So and each region will have its own redundancy steps. So in such cases, you have multiple nodes, not just 3 nodes. You'll have multiple nodes, and they could be spread across the regions, not just in availability zone. They're spread across the regions. So and they're globally located in different locations. But Kubernetes master can manage all the nodes, provided, of course, the basic important thing is they all connected over internet. So as long as a master could access the node, it can control sitting somewhere in, for example, the master could be in US, and the node could be somewhere in South Africa, or even in different region. So that is also possible. So basically, yeah. So the nodes could be within the same region, or it could be outside a region also. I mean, in different region also. So it's all possible. And what is the communication between this master and the nodes? So that is something that we see in the architecture when we really see the diagram. But I think to know it very simple, the nodes will generally communicate to the master about the status. Basically, it's just like a master and student kind of a scenario where master gives instructions to the students, and students will execute that homework or whatever, and then respond the status back to master. So the same concept. So the nodes will communicate their status information back to the master, and they all use something called Kubernetes API. So they know Kubernetes API. Kubernetes API is one of the important component in this master. So this Kubernetes API, everything talks in terms of APIs. So the API will give instructions. Kubernetes API and master will give instructions to node, and Kubernetes nodes will again send the instruction back to master saying on Kubernetes API. And also, we from outside, we instance like a developer, a deployer. When you give instructions to Kubernetes, I think looking at the demos you saw, right, the kubectl commands that we gave. The kubectl commands also internally talks to Kubernetes API. So basically in master, something that you need to remember is Kubernetes API. That plays a very, very important role because all the communication to the control plane happens through Kubernetes API. Kubernetes API is one of the components. There are other components also in the control plane, but that we will see when we look at the architecture. But Kubernetes API is one of the component, a critical component, which talks to the external world. So, I mean, you as a developer or a deployer, you are talking via kubectl commands and from outside world. So there again Kubernetes API is used. Similarly, nodes giving the status back to the master, there also their Kubernetes API is used. Yeah, so that is something to know about the internals. Any questions here? Okay, let's move on. So next one is we also saw about, it also we should know about deployment. I mean, these are some terminologies within Kubernetes. I'm just making you familiar with the terminologies. So this Kubernetes deployment is also again in the previous scene you just created the nodes. So at this point nothing is running in these nodes, but you need to deploy something to the nodes, right? So at this point I'll just show you the. I mean, I just deleted all the components which I created earlier. I'm just connecting to Google Cloud Shell just to show you this commands. So while at this point, yeah.
Yeah, one question, right? Like, so you mentioned about the API, right?
Mm-hmm.
Is all the administrative operations through that API?
Yeah, everything. I mean, happening? Yeah, everything is API. I mean, all the commands. I mean, generally, the command line is most popular interface to communicate to master. So, especially the kubectl that we use. So the kubectl is a command line, but internally the kubectl will talk to Kubernetes API. Similarly, of course, if you're comfortable using Kubernetes API, I mean, you can also very well use Kubernetes APIs directly from also. So, but I think the most commonly used is the CLI route, which is the kubectl route. Yeah, but everything. I mean, even the commands also will internally execute this Kubernetes APIs.
Okay. Kubectl is internal, so like actually communicating through the API.
Yeah, right? Yeah, exactly. So I'll just quickly take you to the architecture, but I will come back to this. But this is what this to answer the question. This kube API server is what is the area. I mean, this is where one of the important component which talks to the nodes also, and also the external sitting outside invoking a kubectl command. He will also give instructions is actually giving instructions to kube API server. So I'll come back to this, but anyway. So, but kube API server is external world talking to control plane. Is also to kube API server, and nodes, individual nodes, the 3 nodes for example, they're talking to the master is also through kube API server. Yeah. Okay. So, yeah, I'm going to show you this. Connect to this. Just connecting to this node. So basically, this I'm from command line Cloud Shell editor. I'm trying to connect to my Google Cloud. So now I've connected to my project, which is this Team Spider. This name is something random it generates. So yes. So if we go here back to Kubernetes engine clusters. Okay. Yes. Yeah. So this. Yeah, so at this point, I just deleted all the previous instances that we deployed. So if you see this, I just applied the delete all commands. So basically, if you just see the deployments, there aren't very deployments. I mean, yeah, the no resources, get service, there will be no resources. And this is a default Kubernetes service, it's nothing to do with our hello world example. Get pods is also no resources, get replicas, that is also no resources. So I just want to show you that we are all, at this point, we are clean. When there's no deployment happened, I'm setting a scenario where I just created a cluster and nodes, and 3 nodes are there. Okay. At this point, there's nothing is running in this because I deleted everything. So you see there are no resources running on this. Basically, at this point, 3 compute nodes with talking to a cluster. So that is what is set. So now I'm just going through each so that you understand what at each point what are the components that are getting created in the background. So there's one master and there are 3 nodes, but nothing is running at this point. Now let's go to the deployment. So the deployment step is where actually we want to deploy something, right? Because the purpose of creating the nodes is to deploy something there. So when we want to deploy something, do we need to directly connect to the VM and deploy it? No. So we'll always talk to master. I mean, the nodes you can access it, but in Kubernetes world, you always talk to master, not to the nodes, because master is the one who dictates what to do for the nodes. So all your interfacing point is your master. So when you give all the commands, the kubectl commands, actually you're giving instructions to the master. So the master will execute the instructions behind the scenes, which you don't see. But again, it's important to know what is happening behind the scenes. But the commands are pretty simple, right? I think whatever we saw that day. So hardly 10 commands are there to talk to master. But we should know what is happening behind the scenes. So when you want to deploy something, so that's where Kubernetes deployment will come into picture. So deployment is nothing but you are giving instructions to control plane, and so the control plane will schedule that deployment into the nodes, so to the individual nodes. So that is what is deployment is. Basically, you are giving instruction to the deployment instruction to the master, and master will create your pod, for example. Your pod is a deployment unit, so it is deploying it into your node, which is ultimately containerized app. So and also this deployment will need behind the scenes. It also uses something called deployment controller. Okay, so the deployment, again, I'm just a lot of terminology within Kubernetes. I'm just making you familiar. Deployment controller is something which will continuously monitor the instances. So and we'll check whether something is down or something is not running for whatever reason. So so that the deployment will be you'll be giving instruction to the master, and master will deploy that instance into the node. And behind the scenes, deployment controller also will start monitoring this guy. So I mean, he's like helper to master. So the master manages overall, but every node will have a supervisor. So the supervisor will monitor whether this guy is doing is he doing the job or not. So is active or not. So a supervisor is inside each node to monitor the status of this pod. So this guy, the deployment controller, is something who is inside this guy, and he'll monitor the instances. And basically, the deployment controller's job is to see whether the node, I mean the node is, I'm talking about the virtual machine, or the instance, which is your hello world application that you deployed. So both your node and the instances, if they go down, deployment controller will immediately give heads up to the master and say that we should now, it's time to replace either a node or a pod, whatever is down. So that's where the self-healing will come into picture. So and yeah, again, so how will you create a deployment? How will you manage the deployment for external user, which is a deployer or a developer? So he will use the kubectl commands. So and also this kubectl again uses the Kubernetes API, which is in the master Kubernetes API, and it uses Kubernetes API to interact with the cluster. So yeah, so basically, if you look at when you give this command kubectl create deployment, I mean this is what we already we ran in the demo right last week. So kubectl create deployment and followed by your deployment name, hello world REST API, and your image. If you look at, if you're not giving jar, the olden days is like you give a deployable unit in terms of a jar or an exe file or binary file. But in Kubernetes, everything is Docker image. So whatever the code that you develop, either in Python or a Java or Ruby or whatever technology node, or so at the end you need to translate that to a container image, and we talk in terms of container images. So, for example, in our case, the hello world container image is something that I created it and hosted it into Docker Hub. So that's why I'm giving a Docker image of my hello world instance. So yeah, so basically when you say kubectl create deployment and you're telling the deployment name and followed by the image. So with this command, when you execute this command, what is happening behind the scenes is you're giving this instruction to the master, and master is looking which node or nodes I need to deploy, apply this instruction, and it will apply this instruction. And there is a deployment controller who will be monitoring monitoring this pod. And if something goes on, so it will inform master, and master will replace with a new one or a new instance or a new node. So that's where this how this works behind the scenes. Any questions here? Okay, so let's quickly run that command and so that you understand. I think this is same sort of instructions, nothing different, but I think this is what I'm creating now. I'm just running it. Yeah. So if you see here, this is deployment got created. So now we can say kubectl get deployment. Deployments or deployment both will work. So hello world REST API is there. So at this point, what happened when we execute this command? It actually gave instructions to master, and this guy is now deployed this here. And also you can also look at this pod. So at this point, even the pod is also created. So when you executed this deployment, actually you're giving instructions to master saying I need a deployment. But what is there in the deployment? The deployment has an image. So it has an image. So basically, what it does, okay, master understands that I need to download this image, and also it will tell the pod saying that a node create a pod with the Docker image as this. So that's how it created this pods. Okay. So yeah, now let's understand what is pod in better way. So let's understand what is pod. Pod is nothing but in our case, if you see, there is only one pod that we created, hello world API. But in a complex scenarios, a pod could be multiple container images also. I mean, in my case, it is just a simple one container image which is translated to one pod. So which is this scenario. So a pod with just one hello world image inside. This is a very common scenario. This is what we use for a smaller, simple application like this. But simple web application like this. But imagine generally you'll have an application with database, right? So that in that case you also have a database or a shared stuff between two pods, for example. So So you have, it is possible that it could be more than two components or more than one component could be there as one pod. So I mean, it is possible. It depends on the scenario, what which application you're talking about. Based on that, it is possible to have more than one pods, more than one containers in one pod. So to simplest example, your hello world is created as one pod. That's why when you execute this get pod, so you got one pod, right? So what is pod? Pod is nothing but a smallest unit in Kubernetes. It could be a group of one or more application containers. So more scenario we are not seeing it, but I will show you a complex scenario where you can have multiple containers deployed in one pod. So it is possible. So probably, so this is one of the complex scenario, but I didn't cover that. But I think we'll see an example probably in the next demo. So so at this point, what you need to remember is so pod is nothing but a group of containers. So that is what you need to remember. The group of one or more containers. And when it is one, it is good. But when you have more than one, then there will be something common also across these two or across these three or across these five. There will be something common. So they call as shared resources. So what are the shared resources? In a pod, the shared resources are nothing but storage. Storage is a shared resource because I mean there's a 5 GB space allocated to this pod, so you are sharing the 5 GB space between these three, for example. So and also networking could be common. So so the how these pods can talk to each other. For example, so this pod can call this pod, this pod can call this pod within. So it is possible to have communication between. So so it is so networking is also is common, and also they also share information about how to run a container like image and codes and other things. So yeah, so basically to understand what is pod is something but a simplest unit. It could be one or more containers grouped together, and they share something in common like shared storage, networking, and information about how to run containers. And when you say networking, so this is one thing that you need to know is these pods have an IP address. That is very unique. So this, I mean, even Dockers also will have IP address. So Docker is and pod is similar to Docker, right? So it can also have an IP address. So basically, you can call this pod using an IP address. I mean, just I will show you this. In our case, this is the hello world is a pod that we created because you see here get pods. It printed this. There's another command which gives more information about your pod. So kubectl where you can see this IP addresses also. Something called -o y. So this is like it will give more information about the pod. So if you see here, it gives additional information in terms of what is the IP address. Okay, and also it is telling which this pod is running in which node. For example, 35DR node is where it is running. So you can get more information. So basically, the important thing that I want to highlight is this will have an IP address. The pod is nothing but it's also a networking component is also there in this, and of course this will comes with some space, but it will also have storage. It will also have an IP address. So it is nothing like your application, right? It's a full-fledged application where it has an IP address, a networking component, storage component is also associated. Okay, so that's about pod. And where does this pod reside? They all this pod reside in node. Node is again nothing but this, right? So node is this, and this is pod. So your node. Well, if you discuss about node, I think we already discussed this, but I think the node in a node there will be multiple pods can be there like this: pod 1, pod 2, pod 3, pod 4. Like it can be 4 pods in one node. So I mean, just probably this architecture is nothing but this is how this flow goes, right? I mean, the simplest thing is a pod. I mean, pod is. I mean, I'm talking about Kubernetes terminologies here. Kubernetes terminologies. The smallest thing is pod. Um, so all these multiple pods can be inside a node. Of course, multiple nodes can be a cluster. So if you understand this hierarchy, it will make your life easy. So, so this is cluster is a parent. A cluster can have multiple nodes, and each node can have multiple pods. So it's just a hierarchy. Um, so yeah, and again inside pod. I mean, this is not a Kubernetes terminology, but inside a pod, there will be multiple containers inside a pod. Okay. So this is the hierarchy. So it is, if you see this diagram, this is a perfect example where you see multiple, all these boxes, small things are containers. So all these multiple containers are in one pod. So this is a hierarchy, right? So this node is nothing but a worker machine, and as this is where actually the job is really getting executed, and each pod runs on a node, and the hierarchy that we saw now. A node will have a pod, and pod will have multiple containers. So, and a node, if you look at the node has two components here. One is called kubelet, and one is Docker. I'm not sure you're seeing it. This font is very small, but this kubelet, and this is called Docker. I'm slowly introducing you to the inner components so that when you see the bigger architecture, you'll understand what are the various components inside inside a complete Kubernetes architecture. So this kubelet is the one which actually updates the status or health of a particular node or a pod to the master. So the kubelet will is the smallest unit also inside a node. Again, these two are Kubernetes specific components which will be deployed in a node apart from your pods. So this kubelet is one component, and Docker is Docker or a container engine. Docker was the standard for container engine, but I think just for you to understand the in Kubernetes version 1.20, which is very new, a very recent version, 3 months old. From version 1.20, Docker is not the official container engine. I mean, so far Docker was the official container engine, but in Kubernetes they are moving out of Docker. I mean, Docker could be one of the container engines. So they want again they want to. I mean, Docker has some limitations, so they want to move away from Docker as much as possible and make it generic, so that any container engine following some specifications can become a container engine. So yeah, I think Docker but again, still Docker is more popular and it is widely used. But still, Kubernetes is slowly moving out of Docker. Uh, um, so I think yeah, this Docker will when you're giving this image, which is a container image. So this image is nothing but a Docker image. But of course, you can build that image with Docker or something else also. But yeah, so Docker is mostly used. So basically, if the node dies, all the pods inside this node also dies. That's something that we need to keep in mind, because the node is nothing but a virtual machine, right? If the virtual machine dies, all the contents inside this also will die. So which internally telling you that pod also can die. So the areas where you need to focus in a Kubernetes deployment is you should always think that everything can fail. A node can fail, a pod can fail, especially these two. Because cluster can't fail, because cluster, I mean, generally the possibility of cluster failing is less, very less, because cluster has multiple nodes in it. Right? So a possibility of cluster failing is a possibility, but still it is less. But the highest possibilities are a node in a cluster going down, or a pod inside a cluster going down. These are two possibilities that can happen. So, but Kubernetes has the capability to self-heal itself. So that we'll see when you look at the self-healing part. But yeah, these are the basics. But I think hope you're clear in this. So, any questions here in this slide? Okay, let's move on. So now let's look at service. So again, this is also another terminology within Kubernetes. So as you see here, this node has multiple pods, right? So each pod has an IP address, 10.10.1, 10.2, 10.3, 10.4. So there are four IP addresses associated for each pod, right? So so this and these pods also we're telling that these pods can die, right? So the pods are ephemeral. So anytime they can die and a new pod can come back. Same applies for a node also. So when they die and come back with a new one, so this IP addresses are something that will change. Um, so when you want to give some external person this hello world website URL, this I mean you can't give this pod IP because this pod IP could be valid now. Probably the next hour it may not be valid. The IP because IP is changing if it dies. If it doesn't die, that's good. But if it dies, the IP address will change. So you can't if you want to want a stable URL, irrespective of whether these pods die or not. Want to give a stable URL for outside world so that they can access hello world application. So we need something else which will give a stability to the connectivity to pod. So that is what is called service. So in Kubernetes, service is nothing but a load balancer. You can imagine the olden, it's nothing but a load balancer. So the load balancer, if you remember our general load balancer concepts which we learned in the past, right? So load balancer, nothing but behind the load balancer there will be multiple EC2 nodes or virtual machines will be there. So that is a non-Kubernetes world. So where there will be load balancer behind there will be multiple EC2 nodes or Azure virtual machines will be there. So the same thing here, the virtual machine here is nothing but pod. So so this pods will have an IP address. So and each pod is deployed in a different node, right? So and each will have an IP address, and this pod can die anytime. So we need one outside person, one URL which is always fixed, so that you can share this URL to outside world, so that they can access the hello world application. So, but internally behind the scenes, it should take care of when my service is coming, when hit is coming from outside world, it should know which pod it is alive and should send the traffic to that pod. So that is something which the service will do. So just to understand, pods can die, pods IPs can change, but we need a fixed URL for the external world to call, and that is what is called service or a load service of type load balancer. So there are a lot of types are there. Service of type load balancer is what we expose. So this URL is always fixed. I mean, this IP is always fixed. So, but behind the scenes, the networking magic will take care of transferring your hit coming to this IP to whatever pod at that point it is alive. So that the translation magic from this to any of this is done by the load balancer. So that is what is this Kubernetes service. And if you look at again, yeah, so like pods are ephemeral and also nodes also are ephemeral. They can die and come back. So just to handle the traffic, you have something called service. So service enables a standard networking endpoint. The stable networking endpoint. So which means you'll have a fixed IP. If you have an IP, which fixed IP, you can also associate a DNS to it. For example, Srini.com, Sham.com. So you can assign a DNS to that because you have fixed IP now. And of course, a standard port also is required. So, so at any given time, someone is trying to hit helloworld.com, so which is having this fixed IP and port behind the scenes. It will translate your traffic to any of the hello world pods that are running inside the Kubernetes cluster. So and also when we're also telling that the pods can die, so there should be someone who will ensure that the replicas are maintained. Uh, Sorry, 1 minute. I need to step out. Someone is knocking on my door. 1 minute. 1 minute. I'll be back.
So, what did you guys learn now from the Kubernetes to the Hinduism? Do you guys see any connection? Jnani, humans can die, anybody can die, but Atma is going
Oh,
to be always
Atma.
there. Atma. So, service is an Atma.
Oh, that
See,
suddenly you are kind of transcending into spiritual world. I don't know.
Illada, see,
Container
I
world.
think, no, you're missing the point. The Kubernetes got all these lessons from Hinduism, and
Hmm.
they are translating it. That's it.
Mhm. Hey, back. I'm back.
Yeah,
Understand?
we can establish like the Vedanta theory versus Kubernetes.
Yeah, and we didn't patent it well. Otherwise, you could have got a lot of money, right?
Yeah.
Only
See?
the application will work actually,
Yeah.
not. Uh, you can establish it now that this is the pirated software.
Yeah. That is the Cloud Ananda to the Kubernetes Ananda. We do all those things, spiritual side of it.
So in case the scripting is to be done, probably we cannot do it using the IP, right? Because the IPs are dynamic. So scripting means at what level we will do? Only at 1.1.1.1?
No, actually, there is an internal something called DNS. So when you create a service, it will have, see, when you have agilerules.com, that is a public DNS, right? Anybody
Okay.
can connect. But
Okay.
when you create a hello world service within Kubernetes, it is creating a private DNS. So all
Okay.
these terminologies, right? Whatever there for last so many years, they slice it into private things as well, so that you get the same benefit of a DNS, but as a private DNS, so that you don't hardcode anywhere the IP address and so on,
Okay.
because anybody can die, anybody can new person can come and so on. As long as you get to the Atma of it, if you Atma, you will always form of shape. You could be a human, you could be an ant, or anything, right? But you will get if you get to the Atma of DNS, you will be good. You'll get an answer back.
Okay. So script should be done at the Atma level, not at the body level. Okay.
Atma level, you got it, man.
Okay.
See, Nani,
Okay.
Okay.
Okay. Yeah, that's true. I think
Good way
the
to remember this. Yeah, Atma. Get to the Atma. Yeah.
yeah. Yes. Yeah. This Atma is service.
Yeah.
Yes. Yeah. So yeah. Yeah. I mean, whoever listens to this video, recorded video, no, you confuse what is this? Non-Indian. Uh, okay. Yeah. So if you look at this service, right? So this 1.1.1.1 is a fixed IP that you get, and of course the port there could be some port that the service could be running. So that port. So that way you have IP address and port. So with that you can link to a DNS also. So that way at the end you get a DNS or a IP call and port fixed, so that when you can give this to external world, so everyone can hit our service. But behind the scenes, yeah, it will route to the respective pod's IP, which is dynamic. So and and also this, as I said, this pod can go down, right? So someone should monitor this pod also and bring that up. When you say three is my replicas, I mean I need three instances of this. So something called replica set again is another terminology. So within Kubernetes, replica set RS is the one which ensures that three instances is what you, three pods are what you're looking. So the three is always there. So that is what this replica set will ensure. And they all will be part of a deployment. So which is this. So if you look at this this when you execute this command, just before this, I want to show you that there is no services are there before. If this, basically, what I'm trying to do is now. In the previous command, we just executed created just a pod, right? So the pod is now inside this Kubernetes node, and we give only one pod, and only one is running, and one out of the three nodes, only one node it picked, and it is running in that pod. In that node. So one pod is now running in one node. So that is what the current state is. Now, what I will say is I will instruct Kubernetes to also probably I will add more replicas to it so that it makes sense. So probably I will go back to the replica command. Yeah, here. So I'm just asking to scale the instances to 3. So with this, I'm just showing bringing to this architecture. So at this point, only one pod was there. One pod is there. So I'm making it to 3 now. So with this, I'm bringing to replica is equal to 3. So it's now done. Okay, I can come back to this kubectl, get pods. Now shall 3. I will also give you the -o wide, which will show you 3 different IPs. That is what again this I'm showing back you to this architecture. If you look at these 3 pods are there, and 3 pods are having a specific IP address. So these are this IP address. And if you look at it is for example these 2 pods. It is again decision of Kubernetes master. Master decided to take to use same node for this pod 1 and pod 2. Probably this one is in a different pod. Sorry, different node. Sorry. Sorry, pod and nodes are confusing. So this pod 1 and pod 2 are deployed in the same node, 35DR for example, and the pod 3 is in a different node. So basically, if you come back to this architecture, so this you can imagine out of the 3 nodes, you can imagine 2 boxes. 2 boxes are there here. 2 pods are there here. You can imagine this is this node. 35DR is this node. There are two hello world pods are there in this 35DR, and BBHQ in this there is one pod. So basically 2 in this pod, 2 in this node, and 1 in this node. That's how master decided. Again, that is completely master decision. You can also place in all 3 also, but it didn't use this for some reason. So yeah, so that is the idea. So now you have 3 IP addresses. So if you want to give to external world, which IP you will give? So that's the confusion. And this IPs also can die, and then you can get a new IP. So that also you can see. Probably let's see that concept. Let's kill a pod. But we'll delete. I'm just deleting this pod. And now replica set will kick in. If actually delete pod. Yeah. So it actually now replica set will kick in, and actually this will ensure that your pod is again 3 are running. So I will just look at the -o wide. So if you look at the 20 and 9 are still there. I think we deleted the first one. So 19 has become 21. This IP has changed now, right? So basically now this IP is changed from 19 to 21. So this is what the scenario is. Like this scenario is like the pods can die down, and it can when it comes back, it comes with a new IP. So now how will external world external world needs a static IP, right? So that's where this we need something called Kubernetes service, which we need to expose. So I just showed you that there is no services running here. This is empty. If you see here, this screen is empty. Now once you create a load balancer, I'm now creating a load balancer now, so that I get a static IP.
So Sham, one thing I think So you said service, right? Like, so if I want to just run one kind of what you call kubelet, right, and expose it, there used to be called something called node port. Does it sound familiar to you?
Yeah, node
That
port.
is the way you expose the internal IP to
Yes, exactly. I mean, node port will work as long as you are within the cluster. I mean, this is node port is one of the services. I mean, when you use this type, we have a type called there's something called type. This type, there are various types. One is load balancer is one type. Node port is one more, and something called cluster IP, and there's something called external IP. So external, I forgot external DNS or something. So something called these are four types that are there. So each type has its own meaning. I think I'll come back to that, but I think this node port is one of such type where with node port you could access not from outside. You can access within the cluster, meaning within the cluster. If you want to access it, you could access it. For example, I could access this by connecting to this cluster. I could access this curl via curl command, for example, or I could access this endpoint, but not from outside. If you want to give from outside means you need to have a load balancer. The scope matters actually. The scope is global versus scope is cluster. The scope is global, then you need load balancer. If the scope is within the cluster, meaning within any node you want to access it, not from outside. I mean, you want to keep it private. You don't want to expose it to outside world. Then you can use node port. I will come to that. So yeah. So I'm just showing you the load balancer as a type now. So I'm just selecting here. This one is. If you look at this command here, I'm exposing a deployment of type load balancer and telling to port 8080. Going back to this diagram, so it is nothing but I'm creating at this point a service with I'm not telling the IP address, but so that because this Kubernetes will decide what will be the IP address for it, because so that is because the IPs are completely managed by Kubernetes. So I'm not telling the IP, but I'm telling the port. I want this port. You decide the IP, but the IP should be fixed. But the port is what I'm deciding, which is 8080. So basically, whatever the IP that we get, colon 8080 will be the fixed IP for IPN port for this, which is called service. So now outside world can access this.
This is similar to what you have in Unix. There is a services file, right, where you say, okay, HTTPS is 443, HTTP is 80. So similar to
exactly,
that, right?
Exactly, yeah. So in typical web server, you create a config like Nginx config. You tell what is the port you want. So that is something, yeah, you're deciding here. Right. So yeah. So with this, I'm telling you decide the IP, but you give me fixed IP. But port is what I'm deciding 8080. So if I run this command, now we get a fixed IP. So now if I go back to my load balancer, so I want to know what is my IP now, right? So fixed IP. So that is something. I mean, Kubernetes is very intelligent. There, I mean, the Kubernetes they're not getting into the networking aspect more in detail, and they're giving this control to the cloud. I mean, it's pluggable here. That's what I'm trying to highlight. The load balancer here is a cloud component. You see here it was empty before, and we got some hello world entry here. So it is actually creating. Still, it is not done. So I'm just refreshing it. You should get an OK. Yeah, OK. So if you look at here, at this point, an external load balancer is created. So now this is a fixed endpoint that you got. I mean, since you decided 8080 is my port. So this is something. This IP is something that is picked up by the Kubernetes itself. So now you can access this endpoint. So yeah, this is where your IP, fixed IP and port. So now you can give this to anyone. You can also access this this IP, for example. You can also try this your endpoint, and this will work for you because it's something global. So I'll share this link so we can give it a try. I'll share a chat. Okay. Probably reach this. And we need hello world. Actually, this is our hello world endpoint. You can try this as well. From your machine also you can try this. It's a global endpoint. Anyone can access it. So this is what you get as an external endpoint. So what is happening? You seeing my screen? You're seeing my screen, right? Hello.
Yeah.
Yeah. Okay.
Yes.
Yeah. Okay. Yeah. So so at this point we got an external load balancer and we got an fixed IP and port. So that is that is what. So again, behind the scenes, what is happening? So behind the scenes, the load balancer is something that is created. It uses the Google's load balancer. So I probably can show you that when you created nodes, we saw the virtual machines, right? Here, I'll show you here. If we go here, go to the networking. Yeah, load balancing. So you went to the wrong screen. So networking load balancing. If you go here, you will. It is creating a Google Cloud's load balancer. So if you see here, this is the 745 is the name, and of course then it's like there's one target for 3 instances. So and it's running on TCP. So yeah, this is what it is created with load balancer behind the scenes. So it is basically, if you look at Kubernetes is deciding the node is something that is given to the cloud vendors because Azure has a different way of creating a virtual machine, same way for Google. And also the load balancer, when you ask for load balancer, again, Google created its own load balancer and gave you a static IP. If you did the same thing in Azure or AWS, it uses that respective clouds, Azure or AWS load balancer, and creates an IP address for you. So that is what we need to remember that. So basically, it is wherever with Kubernetes. I mean, you see you see the bigger picture of Kubernetes. So you can plug in whatever components you want. In this case, the load balancer and especially the virtual machines I'm talking about, the compute and the load balancer. So these two are pluggable. So you can use your own compute if you're doing on-premise, and you can have, let's say you already have a load balancer, you can use your on-premise load balancer. If you're on cloud, you can use cloud's components also. So that piece is given to the implementer. I mean, in this case, we're using Google's, or it uses Google's, or if you're using on-premise. So that is the beauty of Kubernetes. So it is not giving the complete components. It is giving all the interfaces to you, and the interfaces can be plugged by any cloud or on-premise solutions. So yeah.
So tying back to our religious thing, based on your faith, right? Your Atma is realized.
Yes.
So if you are on premise, that means if you don't believe in any religion, still it's fine as long as you know what it is. That's it.
Yes. So if you come here, services and ingress. So this is your I mean, if I'm just directly clicking here. course, you can also get. I mean, this is just to show you the various your health of your pod. What is the CPU and what is the memory and what is the disk and other things. And also, this gives some additional information about about your load balancer and what is your IP addresses. And yeah, the load balancer is something here 745. I'm just opening a new tab. This will take you back to that load balancer that we saw, the load balancer tab. It is taking you to the load balancing tab. Okay. So yeah, so this shows that it is internally using your Google Cloud's load balancer, and this is the load balancer, and these are the three EC2 instances. So not EC2, I mean the virtual machines that are deployed here in different zones. Okay. So yeah, let's come back to this slides. So so that is the advantage of the service. Now we understood service. Service is a load balancer. Load balancer will use static IP and port so that you can you need not know the internals of this pods, IPs, and other things. So it's completely hidden for you because they're all flexible. They are very dynamic. You can change. Right. And then one important thing now, how will these labels and selectors? So now the question is, okay, you're telling this pod is IPs are changing every time. Even the same question will be applicable for service. How will service decide what is the IP address of a pod at any given time? Because pod can die down and you're telling the IP address will change. So even how service will know that information? What is the latest IP of a pod? So the answer is Kubernetes magic is because the IP addresses are dynamic, so it is not relying on IP addresses to identify a particular pod. It uses something called labels. I mean, we never thought labels will make such a big impact. Labels are like a metadata, right? I mean, generally when you create a virtual machine, you say you can also give a tag or a label to it saying this is for project A. So, I mean, that will help you to identify that node when in a virtual machine by looking at a label. Oh, this is for project A. So, but here labels are very, very, very crucial because the service itself is depending on these labels to decide where the traffic should be routed to. So, but yeah, so what is labels? Labels are nothing but just a key value pair. I mean, you can give project is equal to, for example, I'm just giving an example. So this it could be project, or it could be your hello world, or it could be anything. I mean, you can give any name to it. I mean, it's just free flow. So here you can also give A, for example. So labels are the ones which service should know, and whenever you're hitting a service, so the service will also have a label about the pods about the pod labels. So whenever hit comes, it searches for the pods with those labels, and it will route the traffic to those pods. I mean, for example, let's say there's a fourth pod here out of three. There is also a fourth pod which is not related to hello world. I mean, something else. But your traffic should not be routed to that fourth pod. I mean, the traffic should be restricted to these three pods. So how will that happen? That happens through labels. The labels associated for each pod, and that's how you are grouping it together. These three pods are related to hello world. An app is equal to hello world also could be one label. So app is equal to hello world will tell that whenever as traffic comes, it will route your traffic to only the pods which are labeled as hello world or A here. So, and there could be some other app, there could be another service or a pod which could be with a different label also. So again, Kubernetes doesn't define what a label or how a label should be. It's free flow. You can decide it could be app or it could be something else. So the key and value, your choice, because you are the one who is creating this pod and creating the service. So, but the only thing is, every time you create a pod or service, you should remember the label. That is what is important, because all the traffic routing is happening through that labels. So becomes, I mean, suddenly, I mean, this is something very I was having this question, how this works internally. I mean, then I realized labels. The labels generally is like a additional information. I mean, generally in the virtual machine world or any other clouds products that we saw, labels are metadata, like additional information. But suddenly that become a crucial here. So that is something, yeah, which is unique in Kubernetes. Like labels and selectors are key for the service to decide which pods the traffic should be routed to. Okay, so that's about the service and labels. Any questions here? I mean, we have not seen labels in this case, but we'll see an example for with labels. Any questions here? Okay, so summary here, we saw load balancer, type load balancer, and when we created load balancer type and we executed this command, and it internally created Google's load balancer internally and exposed this port, and it gave a standard static IP to you so that you can access that. There are various types of load balancers. We saw only one type. There are other types are also there, which will go in the following slides. But at least you got some idea of how this works, right? So let's go further. So if you look at here, now we also saw something called rolling updates. So the rolling updates scenario, before going to that, I will show you. I mean, the rolling updates is a very important one of the deployment strategy. I mean, Kubernetes follows a lot of architectural patterns or design strategies. So one of the very popular deployment strategy is rolling updates. Rolling updates is, I mean, again, it's nothing new. I mean, we know that already. It is just a terminology that you need to be familiar in Kubernetes. The rolling updates is from the name itself, right? You have version A that is deployed, and tomorrow you want to deploy version B. Sorry, let's say you're deploying version 0.0.1. You want to deploy 0.0.2. So when you deploy the 0.0.2, we have a lot of patterns there where you want to deploy 0.0.2, you can completely stop the olden ways of doing it. So you completely, even now many people do this, right? I mean, whenever you want to deploy something to production, the strategy that is followed is they will stop the old service, deploy your new service, and then start, and then everyone will get the new service, right? So, but the drawback in this process is there could be some people who will be already using the old service, and they couldn't use it because there is a downtime during that maintenance window. That's why all the production deployments will happen on a weekend so that the impact is less. But again, but there are some applications where they can't go down at all. So for such cases, one of the popular strategies that is followed in the older days also is that rolling upgrade strategy. And Kubernetes uses the rolling upgrade as a strategy, default strategy. So, I mean, you understood the difference of, I mean, the rolling upgrade is nothing but the olden days, I think you deploy the package on a weekend, right? The production deployment happens on a weekend, so that there's a downtime involved of the system. But the same thing, imagine a scenario is like go downtime because your application is super critical and there should not be no downtime for production deployment also. If that is a scenario, then the very popular deployment strategy that you follow is called rolling up. Sorry, rolling upgrade. So this is one of the popular deployment strategies. As per this model, you do the deployment gradually. So that is the beauty of this rolling upgrade strategy. So you will not shut down all instances at one shot. So you slowly, rolling upgrade requires at least, for example, multi-node. Otherwise, the rolling upgrade will not work. But imagine there's a 3-node cluster, and you have to deploy this strategy. So then there should be no downtime. So the strategy says there's no downtime. So at the time, first you bring the node 1 down, but the node 2 and 3 will be up. Node 1 is down, but the node 2 and 3 is up. So, and then you do node 2. then node 1 and 3 are up. So likewise, there is node 3. So this is it's a gradual deployment, and finally you completely shut down the older version. So that is what this rolling upgrade is.
Yeah, a good analogy is like a shift system, right? If you are having 3 shifts, the first shift person doesn't leave until the second shift person shows up, and then they kind of hand over to the other guy and then move on.
Exactly. Yeah.
So that's the kind of, and this is ties into this CI/CD pattern where it is continuous integration / continuous deployment or delivery, right? So Twitter is a good example of that. Like they kind of claim that whatever you write, immediately if they can deploy to a particular region, test it, and then move to the other regions. And this is I think this rolling pattern is what is used actually in this.
Yeah, exactly. That's true. Yes. So this and Kubernetes. I mean, this is one deployment pattern. There are other deployment patterns are also there. I mean, I'm talking general. The deployment strategies are all bringing down. Rolling update is one strategy. Other strategies are like blue-green deployment. That is one strategy. Again, these are all various strategies. But I think Kubernetes follows rolling update strategy. So as per rolling update strategy, again coming back to this the diagrams that you saw. So again, the master and 3 nodes, right? So and let's say your pod, hello world pod is now running on all these 3 nodes, and this is running on version 1. Okay, and now you want to deploy version 2. So when you again, as I said, Kubernetes uses rolling upgrade strategy. So this is how when you give a version 2 to it, which is highlighted in this purple color. So first it will deploy your version 2 in first node, and slowly delete this old version 1 node, one instance, and will deploy version 2 in one node, not all the other nodes. Your updated app, for example, is this version 2. And now you get a new IP for this. The old IP is 0.5, new IP is 0.6. So you get a new IP to this. But anyway, you have a service, so you don't need to worry about it. The service is a super saver for you because IPs are changing, doesn't matter. Service will take care. So now, now at this point, I mean, 1 minute later, let's say, once you deploy this, your latest is there only in one node, but not in all 3 nodes. Now service is everything will work fine. Even the traffic that comes to your this only for this node, it will go to this new service, but I think the traffic for the rest of the nodes will go to the older version. But end user will not see that. There's a downtime happening. So end user will, based on where he is, he might either get a V1 version or a V2 version. So it depends on where the traffic is getting routed by the Kubernetes. Now slowly Kubernetes will try to deploy it. It will again look at the health when it's trying to deploy it. If it is good, then it will deploy it into other nodes. So it is deploying. It's a slow strategy. So it first deploys, checks, monitors for a minute. Okay, it's all good. Then okay, let me roll on to other nodes also. So it will roll on to other nodes, and finally you get the same instance, the purple version, which is a version 2, is deployed on all the 3 nodes. So, but again, everything you will get a new IP, but doesn't matter for us because our saver service Atma is there here. So he will take care of the IP address changes also. So yeah, so that is a rolling update pattern, and the Kubernetes follows the rolling update pattern. So when we talk about cluster, rolling update is one of the popular, most suitable pattern in this case. Of course, you can also change other patterns also in Kubernetes, but this is by default pattern. Okay. Any questions? I mean, it's just that I want this. This. I mean, I will not be able to depict this in a way, but I mean to show you this very clearly. But what I see is that, I mean, when you deploy this version 1 and version 2, right? So that we tried in the last session. So yeah, for example, this is version 2, right? So I'm setting this version. When I deployed it, I used version 1.001 as for a deployment. That's why when you hit this endpoint, you get version v1, right? Now, when I'm trying to deploy version v2, so I can set this image as version v2. Yeah, set image version v2. So when I setting this command, what it does is you're setting the image and 002 is what I'm giving as my v2. So actually, I'm doing a production deployment. You can imagine that. So yeah, yes. Okay, so it got logged out. So I'm setting this deployment to version 002. So when this happened, actually, you can see what's. So if you see, it is actually terminating slowly. It is. I mean, now if you see, there are 5 nodes are there. This is very interesting to observe. So this is the rolling upgrades pattern. When you deploy it, when you immediately get pods, it is running in 3, but actually there are 5 instances that were created. So it will slowly populate the new nodes and uh, and uh, and slowly at any given time traffic will be at this point routed to 5 nodes, not 3 nodes. Okay, so it is adding more nodes to you, and also it is deploying your node, and at the same time it ensures that it is all in running state, not failed state. If it is failed, then it will not deploy it. If it is not in failed state, then it is slowly terminating the older instances. So probably if I next moment if I type get pods, you will back to 3. See that? So this is a rolling pattern. So basically you are increasing the not even I mean you're deploying it at the same time, but when you're deploying it, you're also even terminating the nodes. So for example, if this is where it is deployed, so at this point it delete it added a new node and it deployed your new pod, but still you are at that moment when traffic is happening, that there are 5 nodes are there. So, but still, end user doesn't know anything. Your service is running and everything is working fine. But once it ensures that these instances are working fine, then it will slowly deploy gradually to all the other nodes and then delete the extra once it is created, so that the impact is less. So again, we are back to 3 nodes status, but momentarily there are 5 nodes, right? So yeah, so that is the beauty of this rolling pattern, a rolling upgrade pattern. So let's look at I think you understood the basics now, right? I think we understood what is cluster, what is nodes, and what is deployment, and what is pod, and we understood the pods could be of multiple sizes, and multiple pods could reside in a node, and there is a hierarchy. A cluster can have multiple nodes. In each node can have multiple pods, and pods can have multiple containers. And the pods are ephemeral, so service is required. And how service will identify labels. And we also understood how this rolling pattern happens behind the scenes, right? So now, if you have to look at what is if you have to club everything together, this is what this Kubernetes architecture will look like. So this Kubernetes architecture has multiple components, and I mean you don't need to know these terminologies because these are all which are internal to Kubernetes. But coming back, I mean it's also good to know them what is happening behind the scenes. So again, this master here is this master, this control plane. And the node here, 1, 2, 3, these nodes are these nodes. Okay. Now you see how what is the communication happening with how the communication happens between the master and the nodes. And this is very important. Spend some time here. If you don't have, if you have any questions, please ask me again. But this is how internally this architecture works. Kubernetes has many components inside. But as an outside person, as a developer, or you need not know this, but I think it will be good that you have to troubleshoot something. This will help. So if you look at this control plane, which is a master component, the master component has, I think we saw this kubeAPI server. We discussed this. All the commands that you're typing, the kubectl command that we saw here, all these kubectl commands, these are all internally talking to kubeAPI server. Basically, you're interacting to the master when you give this command. So master, especially in the master, there is something called kubeAPI server. Is where you're giving that instruction. The kubectl get pods means you're talking to this kubeAPI server behind the scenes, and the master will not know what pods are running. Pods are here in the nodes, right? So it doesn't know what are the various pods. So basically, the master will talk to the nodes, or it will have its own status at any given time in a database. So as long as mostly the status will be up to date, but in case status is not up to date, it will go to the nodes and get the latest status. But kubeAPI server has an internal database. It's again internal database. You are not exposed to this database. So HT is a database. Some people call it etcd or HT. So HT is a database which is a NoSQL kind of a database which is maintained inside by Kubernetes API server. What information is stored in this HT database? At any given time, the health and the node information and the cluster information. Cluster and the node information is all latest information stored in HT. So and now you're also the other components in master, which is called kube scheduler. This kube scheduler role is it decides where the pod should be deployed in which node, and also you can by creating this pod you can also have some conditions like I need this pod in this region only. So we also have such conditions. So they call us pod affinity. So the pod affinity are like conditions for pod deployment. The pod affinity rules can be, if you have pod affinity rules, then pod affinity rules will be considered by this kube scheduler and will ensure that pod is deployed based on the rules you define. So basically it does with scheduler. From the name itself, it schedules the pod in which node it has to run. So in our case that we saw when you deployed this with 3 instances, the Hello World application, we didn't give any rules of where this pod has to be deployed. So the default rule it took is like 2 pods were deployed in one node and other pod in other node, right? So that is decided by the kube scheduler. And then the third component is the cloud control manager. This cloud control manager is a component which talks to the cloud, especially when it created the nodes. It created the Google's virtual machine, and also it created the Google's load balancer. So this component is a pluggable architecture which is exposed so that this can talk to any cloud behind the scenes. Then the fourth component is the controller manager. The controller manager is a component which decides where this instance should run. So it controls the overall setup. So that is what is this kube control manager is. Yeah, so that's about this master. And if you come to the node, node has a few components called kubelet. I think we saw this in the other diagrams also. This kubelet is something which was there here. It's kubelet, right? And also the Docker engine. So these are the 2 components which are required in the node. And these are all Kubernetes components. the again this in a master slave architecture, right? 1 minute.
So, yeah. What do you guys understood? It's all making sense?
Sorry, I'm back. This node has components of kubelet and kubeproxy. This kubelet is the one which tells the health information of this node to the master, and again it talks about kube API server. And kubeproxy, from the name proxy, it's a networking component. If you remember that there's an IP address that is associated to every pod, right? The IP address is a networking component. So that networking component is given by this kubeproxy. And of course, we saw this pod, and pod as a container inside. So it requires a Docker or a container engine also, so that will deploy this container. Yeah, I think probably this one we'll go in detail. We have a few slides which talk some more in detail. Probably I will explain that when we really go there. So probably let's take a break here.
We have a very good dosage today, right? So we'll go deep dive next class.
Yes.
Thanks, Shyam. Yeah, it was good.
Thank you. Bye-bye.
Yeah, bye.
Everyone. Thanks, Shyam.
Thank you.
Yeah.
Thank you.